Hi everyone. Today we're going to study partial fractions. In this video, we shall consider partial fraction form of algebraic fractions. Let's begin with proper fraction. Let us define proper fraction. Given a fraction p of x over q of x, if the degree of numerator p of x is less than the degree of denominator q of x, then it is a proper fraction. In this video, we shall consider 4 cases. This is case 1 for non-repeated linear factors. And this will be the form p of x over x minus a times x minus b. The partial fraction form will be a over the first factor x minus a plus capital B over the second factor x minus b. Let us see this example. X plus 4 all over x squared plus 5x minus 6. Let us factor out our denominator. So we have x plus 4 over x plus 6 times the quantity x minus 1. So the partial fraction form will be a all over x plus 6 plus b all over the second factor x minus 1. Let's go to case 2 for repeated factors which are linear. This will be the form. In the general form given here, this is a combination of case 1 and case 2, the repeated factors. Whereas we can see here p of x all over the x minus a times the quantity the square of x minus b. The partial fraction form will be a over the first factor x minus a plus b over the second factor without the exponent, so x minus b is here, plus c over the square of x minus b. For our example, let us consider 6x plus 7 over the square of x plus 2. The partial fraction form will be a over x plus 2 plus b over the square of x plus 2. Now case 3 will be for non-repeated quadratic factors. So the form is p of x over x squared plus a. The partial fraction form will be ax plus b over that denominator x squared plus a. As an example, let's have 3x squared plus 2 all over x minus 2 times the quantity x squared plus 1. The partial fraction form of this example will be a over for that linear factor x minus 2 plus bx plus c all over this quadratic factor x squared plus 1. Now case 4 here is a combination of case 1 and case 3. The form will be p of x all over x minus a times the quantity x squared plus ax plus b. The partial fraction form of this type will be a over the x minus a because that is linear. Then plus bx plus c all over x squared plus ax plus b. Take note that this x squared plus ax plus b is non-factorable. Let us see this example. 5 over x cubed plus x squared plus 10x. We can factor out the denominator to be x times the quantity x squared plus x plus 10. Take note that this quadratic function here is non-factorable. So we can write the partial fraction form to be a over x. That is the first factor, that is linear, plus bx plus c all over x squared plus x plus 10. Take note that in all our examples, in the cases, we did not solve for the values for a, b, and c respectively. We shall do that in the next video. Now for improper fraction, defined as given a fraction p of x over q of x. If the degree of numerator p of x is more than or equal to the degree of denominator q of x, then it is an improper fraction. As a rule, let us divide the numerator by the denominator and resolve into partial fractions as presented earlier. In this video, we're going to show a sample problem for non-repeated linear factors under the topic Integration by Partial Fractions. This is the sample problem. Evaluate the integral of x plus 4 all over x squared plus 5x minus 6 dx. Let us copy this problem down here. Take note that the degree of numerator is less than degree of denominator. Therefore, this is a proper fraction. Let us copy this fraction on the side. Then, let us factor out the denominator. Factors will be x plus 6 times x minus 1. Analyzing the factors, we can see that these are non-repeated linear factors. Let us resolve this into partial fractions. We have now a over the first factor, x plus 6, plus b over the second factor, x minus 1. Coming back to our integral here, we can rewrite this integral into the integral of x plus 4 all over the factors x plus 6 times x minus 1 dx. Also, we can show this integral with respect to the partial fractions. So we can write the integral of a over x plus 6 dx plus the integral of b over x minus 1 dx. Now, let us solve for a and b. In here, let us multiply by the LCD. Note that the LCD here is the x plus 6 times the x minus 1, the denominator of the left-hand side. The resulting equation now will be x plus 4 equals a times x minus 1 plus b times the quantity x plus 6. This is now our working equation. We say that This equation will be true for any values of x. Now, if we want to solve for b, we want the coefficient of a be equal to 0. In that case, let us set x equals positive 1. It means we will have this 1 plus 4 equals a times 1 minus 1 plus b times 1 plus 6. This 1 minus 1 will give a times 0 plus b times 7. On the left side will be 5. So a here will be eliminated. And we can get the value of b, and that is 5 over 7. Solving now for the value of a, we want b to have coefficient that is 0. So let us set x equals negative 6. Substituting this value, we will have negative 6 plus 4 equals a times negative 6 minus 1 plus b times negative 6 plus 6. This negative 6 plus 6 will give b times 0. And this a will have coefficient of negative 7, while the left side will be negative 2. So the value of a will be positive 2 over 7. From here, we are now ready to substitute the values in the integrals. Here we go. Since the values of a and b are constants, we can move it outside. So we'll have 2 over 7 times the integral of 1 over x plus 6 dx plus 5 over 7 times the integral of 1 over x minus 1 dx. By substitution method, we can now get the final answer, and that is 2 over 7 ln of the absolute value of x plus 6 plus 5 over 7 times ln of the absolute value of x minus 1 plus, we write the constant c, ln c. But this ln c is another constant, so we can simplify this into c. This is now the final answer. Today, we're going to study a sample problem for repeated linear factors on the topic integration by partial fractions. This is the sample problem. Evaluate the integral of 6x plus 7 all over the square of the quantity x plus 2 dx. Let us copy this problem down here. Take note that degree of numerator is less than degree of denominator. Therefore, this is a proper fraction. Let us copy the function on this right side. We observe that the denominator is a repeated linear factors. So resolving this into partial fractions, we will have a over x plus 2 plus b over the square of the quantity x plus 2. We can show our integral here in terms of integrals of partial fractions. So it becomes the integral of a over the quantity x plus 2 dx plus the integral of b over the square of the quantity x plus 2 dx. Now, let us solve for a and b. Let us multiply this equation by the LCD. The LCD here is the denominator of the fraction on the left side. The resulting equation will be 6x plus 7 equals a times the quantity x plus 2 plus b. Simplifying the right side, we will get ax plus 2a plus b. This is now our working equation. To solve for a and b, we are going to equate coefficients. Let's begin with the coefficients for x. On the left side, coefficient is 6, and this is equal to the coefficient of x on the right side, which is a. Let us now equate for the constants. On the left side is 7. This is equal to the right side constants are 2a plus b. We have two equations here, whereas the first equation gave us the value of a, which is 6. Let us solve for the value of b. Let us substitute this value of a as 6 to the second equation. So we will get 7 equals 2 times 6 plus b. Simplifying this equation, and let us isolate b, the value of b will now be negative 5. So these corresponding values of a and b, we're going to substitute on our integrals. So we will get the integral of a becomes 6 all over x plus 2 dx plus the integral of b now becomes negative 5 all over the square of the quantity x plus 2 dx. Since these are constants, we can put it outside the integral sign. So we have now this 6 times the integral of the numerator here becomes 1 over x plus 2. While on the second integral, the negative 5 goes out times the integral of 1. Take note that the numerator here becomes 1. Now let us solve the corresponding integrals. In both integrals, we are going to use substitution method. We are going to set u equals x plus 2. By doing so, the new integral will be 6 times the integral of 1 over u du minus 5 times the integral of 1 over u square du. In the first integral, we will have the answer, which is a natural logarithm, while in the second integral, we are going to use the power rule of integration. So our answer becomes 6 times natural log of the absolute value of u minus 5 times u raised to negative 1 all over negative 1. Simplifying this, and then we replace the value of u as x plus 2, we will get the final answer as 6 times ln x plus 2 plus 5 all over x plus 2, then plus c. This is the final answer. In this video, we're going to show a sample problem for non-repeated quadratic factor under the topic Integration by Partial Fractions. This is the sample problem. Evaluate the integral of this rational function 3x squared plus 2 all over x minus 2 times the quantity x squared plus 1 dx. Let us copy this problem down here. we take note that the degree of numerator is less than degree of denominator. Therefore, this is a proper fraction. Let us copy this fraction on the right side. Analyzing our denominator, we can see that the first factor is a non-repeated linear factor, while the second is a non-repeated quadratic factor. Resolving this now into partial fractions, we will have a over the first factor x minus 2 plus bx plus c over the second factor x squared plus 1. Now we can show that our integral is an integrals of partial fractions. So we have the integral of a over x minus 2 dx plus the integral of bx plus c all over x squared plus 1 dx. Now let us solve for a, b, and c. Let us multiply this equation by the LCD. Note that the LCD is the denominator of the left-hand side. By doing so, the resulting equation now becomes 3x squared plus 2 equals a times the quantity x squared plus 1 plus bx plus c times the quantity x minus 2. This is now our working equation. Let's start by solving for a. We let x equals 2 so that the b and c will be eliminated. By doing so, we have now 3 times 2 squared plus 2 equals a times the quantity 2 squared plus 1 plus the bx plus c becomes b times 2 plus c, and the x minus 2 becomes 2 minus 2. This 2 minus 2 will give us 0, and this 0 when multiplied by 2b plus c will cancel this 2b plus c. Now let us simplify the equation further. The left hand side becomes 14 equals the right hand side is 5a. Then the value of a is 14 over 5. Now let us solve for c. We substitute the value of a in this equation and we let x to be equal to 0. So we have now 3 times 0 squared plus 2 on the left equals 14 over 5, that is the value of a, times the quantity 0 squared plus 1 plus b times 0 plus c times the quantity 0 minus 2. We can show that we can cancel all the zeros in here. By simplifying further, the left-hand side becomes 2, and this is equal to 14 over 5 minus 2c. When we simplify this equation, we will get the value of c, and that is 2 over 5. So we have now two values, which are a and c. Let us solve for b. What we're going to do here is to substitute the values of a and c in our working equation, and we let x equals 1. So we have now 3 times 1 squared plus 2 equals the value of a, 14 over 5, times 1 squared plus 1 plus the quantity b times 1 plus 2 over 5. This is the value of c, times the quantity 1 minus 2. Simplifying further, the left side becomes 5 equals this group here will become 28 over 5 minus b minus 2 over 5. Simplifying this equation, we can get the value of b, and that is 1 over 5. Now the values of a, b, and c are complete. We are now ready to do substitution to the values of a, b, and c in the integrals. This is now the resulting integrals. Simplifying further, this second integral here, we're going to split the sum of fractions of the numerator. So we will have 1/5 of x is here, plus the 2/5 will be here. And we will get that same denominator. Going further, we're going to put the constants outside the integral sign. So it will be like this. Now let us solve for the integrals. Note that the first two integrals can be solved by substitution. It means we can let u to be the x minus 2, and we let w the x squared plus 1. Note also, the third integral is a special formula that will give us the tangent inverse of x. So the next step will be 14 over 5, the integral of 1 over u du, plus the second integral will be 1 over 5 times 1/2 times the integral of 1 over w dw, plus the constant 2 over 5 times the tangent inverse of x. The first two integrals here will give us natural log. So the next step, we will get 14 over 5 times the natural log of the absolute value of u, plus 1 over 10 times the natural log of absolute value of w, plus the 2 over 5 times tangent inverse of x. If we replace the corresponding values of u and w, we will get 14 over 5 ln of absolute value of x minus 2, plus 1 over 10 ln of absolute value of x squared plus 1, plus 2 over 5 tangent inverse of x. Of course, we will not forget the plus c, the constant of integration. This is now the final answer. In this video, we're going to show a sample problem for improper partial fractions under the topic Integration by Partial Fractions. This is the sample problem. Evaluate the integral of this rational function 2x cubed minus 4x squared minus x minus 3 all over x squared minus 2x minus 3 dx. Let us copy this problem down here. Take note that the degree of numerator is more than degree of denominator. Thus, this is an improper fraction. In this case, the first step is to divide the numerator by denominator. It means the numerator is the dividend, the denominator is the divisor. When we divide, we will get 2x. Then 2x multiplied by each term of the divisor, we will get 2x cubed minus 4x squared minus 6x. We subtract the dividend by this polynomial down here. The final answer is 5x minus 3. It means 2x is the quotient. We have the remainder 5x minus 3, and the divisor is the x squared minus 2x minus 3. So the answer can be expressed as 2x plus 5x minus 3 all over x squared minus 2x minus 3. This fraction here is equal to this expression. It means our integral can be expressed as the quotient here. So we have the integral of 2x dx plus the integral of 5x minus 3 all over x squared minus 2x minus 3 dx. Now let us solve this integral here by partial fraction. Let us copy this fraction in here. At first, let us try to factor out the denominator. And the factors are x minus 3 times x plus 1. Note that the factors of denominator are non-repeated linear factors. So by partial fraction principle, this is equivalent to a all over the first factor x minus 3 plus b all over the second factor x plus 1. It means this integral here can be expressed as integrals of partial fractions. And we can rewrite these integrals to be 2 the integral of x dx plus the integral of a over x minus 3 dx plus the integral of b over x plus 1 dx. Now let us solve for a and b. Let us multiply this equation by the LCD. Take note that our LCD is the denominator of the left-hand side. By doing so, the resulting equation will be 5x minus 3 equals a times the quantity x plus 1 plus b times the quantity x minus 3. This is now our working equation. First, let us solve for a. It means we will try to eliminate b. Let us think of a value of x so that b would be eliminated. We let x to be equal to 3. Substituting 3, we have now 5x minus 3 becomes 5 times 3 minus 3 on the left side equals a times x plus 1 becomes 3 plus 1 plus b times x minus 3 becomes 3 minus 3. Now look at this part. The 3 minus 3 will give 0, and the 0 multiplied by b becomes 0. Simplifying now this equation, the left side becomes 12 equals 4a. Solving for a, let us divide this equation by the coefficient of a, which is 4. So the value of a equals 3. Let us now solve for b. Looking at our working equation, let us think of a value of x that would eliminate a. So we let x to be negative 1. Substituting negative 1 to the x, we will have 5 times negative 1 minus 3 equals a times negative 1 plus 1 plus b times negative 1 minus 3. This negative 1 plus 1 will be 0, and 0 times a will be 0. Simplifying now this equation, the left side becomes negative 8 equals the right side is negative 4b. Simplifying further, the value of b equals positive 2. Now we can substitute the values of a and b respectively to the integrals here. There we go. Now, since the values of a and b are constants, we can move the constants outside the integral sign. So it will be like this. Now let us do integration of these three integrals. In the first integral, we're going to apply the power rule of integration. In the second integral and the third integral, we will use substitution method, that later on the answer will be a natural log. So for the first integral, it will be 2 times x squared over 2 plus these 3 we copy down here. The integral of 1 over x minus 3 dx will be natural log of absolute value of x minus 3 plus the constant 2 we will copy here, and the integral is natural log of the absolute value of x plus 1. We can simplify the first expression that we can cancel 2 and the denominator 2 down here. Writing now the final answer, we will have x squared plus 3 ln of absolute value of x minus 3 plus the constant 2 ln of absolute value of x plus 1, then plus c. This is now the final answer. I hope you learned something from this video. See you again next time.